First, I'll introduce myself. I work for Hortonworks. I've worked for Hortonworks the last couple years. I've been interested in big data since about 2015. I got my PhD in the previous year in 2015, master's in 2008, but I've also been a software engineer. So I've been around the space in a lot of different areas. I'm very, very interested in more of an end-to-end use case rather than just building models. So why are we here? As you guys know, in the world of big data, we're in a wash of data. I mean, and we have data from all types of sources. And this data, the volume itself, is actually overloading traditional architecture to the point where you have to start looking at new solutions. And this is where big data architecture comes into play. But the other piece of this too is the different types of data that we have, the variety of data, also really does put a limitation on your traditional infrastructure. So you need a platform that can take large amounts of data and lots of data, and then the other V, if you're following the big V's out there, is the volume of data, but this one's not so much volume. So why else are we here? Other common problems that we see in the industry is that really IT teams and their data science, data engineering teams often are separate and they really don't work well together. So what does that end up meaning? It means that your data scientists don't have all the data that the organization has available to them, and if they did, or let's say they do have some of it and they can create a model, often those models live in isolation, like Luke here on Tatooine. So really, the goal ultimately is to put all your data together, build great models, and then deploy those models into your infrastructure where you can get value from them without putting lots of stress on your infrastructure. So the data set that I'm going to use today is a synthetic data set. It's electronic medical records. The key to this is no one wants to worry about privacy concerns, but you can see some of the table information here. It's going to mostly be like patient information and lab results, and then a diagnostics table, which I'll use all of them when we build the model. The point is, though, it's a fun data set out there. It's EMR bots is there, and that's part of the Droid theme as well. And I'll actually show you the data sets when we get to the notebook here. So the flow will be, we're going to take the data sets, we're going to load them into a notebook, and then we're going to explore the data sets. Initially, what you should do first is try to get an idea of what the data has to tell you in it. And then I'm going to actually sessionalize on the patient information. So we're going to have patients with a condition and patients without a condition, and I need to take all their lab results together and put them together with each patient. So what I refer to as sessionalizing. There'll be some feature engineering, some real basic engineering, actually taking a pipeline model, so not just a model, but a pipeline model, and I'll talk about why I like the pipeline model, and then we're going to deploy the model. So just overall end-to-end, when we get to the demo, this is what we're going to accomplish today. So the first thing, as you guys know, is you've got to load the data. So in this case, I'm using Apache Spark. Apache Spark's an in-memory processing framework that actually is really great. It's really, really fast, but what's cool about it is it allows you to bring in lots of unstructured and structured data where you could then merge and do interesting things with it. It also has Spark SQL that's associated with it. So once you build what we refer to as a data frame, it's the same thing in R and the same thing as a pandas frame, you can actually just apply SQL to it. So there's an API that for data frames, and there's also a SQL style API, depending on what you like to do. I like to do both. And often, some use cases lend themselves one or the other. As I mentioned before, I'm going to pick a target condition, which is mitochondrial syndrome, I believe. And what I'm going to do is I'm going to find the patients that have been diagnosed with that condition, take all their lab reports together and associate to that one patient, or those patients rather. And then I'm going to take control, so all the patients that in the data set that do not have that condition. And that's how I'm going to make an A and a B category. And ultimately, I'll make a classifier based on that. Some of the feature engineering today, really basic things. We'll do some string to index for categorical variables. I will select the features that you need for the model, and then I'll build a vector that ultimately will go into the machine learning model. Here's the pipeline that I was referring to. So if you're not familiar with pipelines, pipelines are a way to take all the transformation steps and what would be the classifier model and bundle them together. And that's interesting because if you look at the lower part of the chart there, what it allows you to do is train and build a model on all the things that you need to do to the features, the transformations, put those together, and then actually when you deploy this pipeline, you can give it raw data. So often the problem is if you build a model but you've done many, many steps on the front end, you have to then replicate those steps for a single prediction, which can get difficult. And what's great about pipelines, and I've got a graphic here later on, is it allows your data science and data engineering team to work together, focused, and actually hand this model off to the IT team. And that's what this demo will show. And so you can still keep your work groups the way they are, which is separated but still working together, but it still allows you to actually get better synergy together. So once the model's been built, they're of no good if they don't get out and they're not being deployed and they're not actually getting good data and you're not getting value from them. So there's a few options to actually take a model and deploy that, and I've been using open source tools to do everything. So there's definitely proprietary software that does this, but I'll show you how I do this. One way to do this using open source software. And then I actually will take that model that has been deployed with a REST endpoint, and I will put that into an Apache NiFi flow, and I will show you what NiFi is here in a minute. But this is a great way to demonstrate how you can actually put a model and actually deploy it and integrate it into your infrastructure. So here is, in a nutshell, what we're looking at today. So steps 1, 2, and 3 are going to be all accomplished with Apache Spark, but I'm going to use a Apache Zeppelin notebook to accomplish that. Once I build the pipeline, I'm going to export it, and I'm going to basically wrap it around a Flask application that's running on a Docker container. So this is a deployed pipeline now with a RESTful interface. And once I have that, as I've kind of mentioned with NiFi, I can now actually send raw data at it. I could send streaming data to this point. And then what I'm going to do as well, just to keep going along here, is I'm going to store everything to Apache Solr. If you're not familiar with Apache Solr, it's very similar to Elasticsearch, except that it's open source. Functionality is very, very similar, though. The division of the roles here, as I've mentioned before, this approach allows you to keep your data science and data engineering teams on one end of the spectrum, allows your IT, your system administrators to be in the middle to control what they're really great at, and then it allows if you have Solr and have a dashboard on top of it, allows your business analysts then to just consume the data and can actually build interesting dashboards. Okay, so. Okay. So what we're seeing here, if you're not familiar with a notebook, this is a notebook. But in this case, this is Apache Zeppelin. Jupyter Notebooks is another great example. I know Databricks has a notebook out there as well. I forget the name of it. It's similar to what you would see the IDE environment with RStudio. A little bit different than that. But what's cool is it allows you to in this case, mix and match, which was Markdown. So different types of languages here. So Markdown, Scala, Python, SQL. It allows you to put them all in one place, and these are shareable with a web link. So often we see groups of people enjoy using these because it's now one place for them to go, and it's often sitting on top of all the data, which makes it nice because then they don't have to download data sets to their laptop. They can take advantage of their large computing environment, and then it's also highly shareable. But I'm not trying to sell anything today, so. I apologize. Okay. So the first step we have here is I'm going to actually load the data files. And as you'll see, these are just text files that are sitting out on the distributed file system, but it could be any file system in this case. And I'm just bringing them in, and in this case they're text, but they're similar to the way a CSV file would be formed. So it's a text file, but it's sort of CSV without the commas, with spaces. So what's interesting is, Spark allows you to actually just read them raw and then bring them into a data frame. This data frame lives in memory. So everything we bring into Spark is all on system memory. It's not actually running on disk. If it gets too big for system memory, it will spill over to disk, and there are options to save things to disk in case you want to save them for later purposes. So, okay. The next thing I always like to do is once I build a data frame, I like to understand the schema of what I'm looking at. Mostly because these data sets I downloaded, I had never seen them before. This is my first real-time working with electronic medical data in this case. And the tables themselves have a really basic schema, but Another the great thing that Spark does is it'll automatically infer the schema. So you throw the data set at it, and it does a really good job at determining what the schema of that column would be. And then back up the truck a little bit, a data frame is, think of it as like a spreadsheet. So in one row has multiple columns. Each column can have a different schema applied to them in the way that you would see in a spreadsheet. So conceptually, it's that. So once I have the data loaded, I just do some, these are just select star statements. These are really basic, as you guys see, SQL statements. So I'm just trying to explore. I refer to this as data exploration at this point. I'm just trying to understand what I have in the data set, and then ultimately what I can now merge together on later steps. So we have patient admission dates. We have diagnosis codes. So once the lab report's put back, but then they're actually tied to a patient ID, as you can see, for example, right here. Well, we're not. We have just general or just lab results. So this is actually the biggest data file that we in this data set, but you can see just the different fields here, the values it would be, the metrics that there would be, all tied to a patient. So what I could tell is, based on this, a patient will have many tests assigned to them for each time they're administered, and they can be administered multiple times as well. As you can, in real life, it's the same way. And then you have some general or demographic information about the patients themselves, male, female, their race, their marital status, for example. The most interesting I thought was for this synthetic data set was population percentage below poverty. I thought that was an interesting feature to have in the data set. It's one I ended up using. All right, so we'll continue here. Based on the diagnosis codes, I'm just trying to determine how many are each out there. And so there's a fair amount of diagnostics or codes that apply there to different patients. Oop, we're back. So once again, more exploratory analysis. I settled on this one, mitochondrial metabolic disorder. I don't know why. I think I liked the code, honestly, which was like 88.4. I don't know. For some reason, I picked that one. But you could easily pick all the other ones and follow the same process here with real data set or a fake data set. All right, so continuing discovery, I wanted to determine which patients, if I could actually determine, I'm doing a nice SQL query here, which patients had that condition that I was looking for, and then just finding all of their information, the lab results. And what I'll end up doing next is a pivot table, which you can see, nope, not yet, next step. So I'm going out there and just grabbing all of the related information with the patients that I have the target condition. Yep, right here. And then I'm finding all the labs, and here's the pivot, right here, for example, which is pretty cool, another cool feature as well, because otherwise you'd have to do something tricky to make that work out. So now I have this point, I have all of the patients related to this condition and all their lab reports on one line related to them. And so we'll call that group A. I repeat the process for the control patients, so all the patients that do not have this condition, and so the same exact thing. We'll call that group B. Let's see. Yep, and then what I'll do is with group A and B, I'll put my hands together and make one large data set out of that. And that'll end up being the data set we'll use for testing and training. But before I can get to that point, I've got some categorical variables that I need to string index. Race, gender, marital status, for example, because the models themselves will treat, you can't send them a he or a she, you have to send them a 1 or a 0, and if you guys are aware, like a 1 or a 0 in this case is categorical, it's not continuous. So the models themselves, if you don't actually go through certain, either make sure that the library will handle them, and often they do, but they don't always, you have to take another step, which we refer to as one-hot encoding, where you actually take a male or a female and you make it a 1 or a 0, that's an easy one, let's say there's 3 examples. But you basically add a binary feature to it that allows the model to recognize that is a category and not 1 is greater than 0. It's pretty important, just things matter. With these models, you can send them anything and they'll give you something back. It's the classic adage, garbage in, garbage out. I selected some features ultimately, and we can talk about that later, but I picked a few features out that I thought were interesting. The next important step here though is building the vector. So taking the features that I selected and actually putting them together in one data structure, which is a single row, it's like a single row struct is what it is. And that's what you actually then feed into the machine learning model. But I will tie to that the label that it had before. So when we go back into evaluations, we can look at those things. But you can see here's the data frame with all the other features. And at the very bottom, there's that vector. So I just tagged it on to the data frame. So it keeps everything together very, very nicely succinct, very clean. All right, from here, I took the big merge data set, and I'm going to make a test and train set. So classic 80-20. This could be different, but for today's example, I figured it was fine. So now I have a test set and a train set. Test, train. And then what I'm going to do is take that data set and apply that to a random forest model. I like random forest models for data like this that can have a lot of variance, just a lot over the place, mostly because you're not going to draw a nice line. You're not going to find some algorithm that's going to fit a nice line for classification. So random forest, I find, does really well on variance of data. And I can talk about that later if you want to talk about that. But I selected that one. It was good for this example. As you would normally do, you need to evaluate your model. This one actually does pretty good, but I'll be honest with you. I mean, anytime you get 999, you're starting to think this is overtraining on the data set, and that's exactly what it's doing. So if I was really doing this in real life, I would bump up my minority class. I would I would try to balance out the distribution because in this case, it's probably pretty close to the number of examples to the control group out there. Next thing I like to do, especially with random forest, I like to rank the features or gradient boost tree the same way. I like to know what is actually the model thinks is important, and I like to rank them out. So in this case, age ends up being pretty favorite. All these values themselves will add up to 1. So in a random forest, that's a good way of thinking of what is the most important feature and ranking them out. All right, and then once I've built the model, I've evaluated it, I'm happy with it, now I'm going to export the pipeline. I'm actually going to build the pipeline first, excuse me. So in this case, we only really had 2 steps. After I selected the features, none of them were strings. But if I had strings in this case, I would just add those indexer steps to this pipeline. And the pipeline is all the transformation steps I took on the features, the raw features, and basically kind of puts them all together. So then you get raw data and it will follow this pipeline. You can actually send, at this point, raw data at this and it will give you a result as well. I will save the model, as you can see right here. And this model I will pick up and actually show you in the application here in a second. Actually right now. All right. Oh. Okay, so I've got a command line here, but how about I just show you this. So once I have the model deployed, and I'll go through all the steps here, I can actually then basically hit it with a simple application in this case. So you can see I've got a previous condition. I was testing this out before, but how about we just, to show you this works, 90, I don't know. So check that value. So you can see this is the probabilities of the 2 class. So in this case, this thing's highly confident that you do not have the condition. In this case, this would be the condition, the target condition. And so the predicted score is 0 in this case. So the way that's running out there now is I've taken that model, I put it into an application, and this is the type of application it is, a Flask application. I've then deployed it to using a Docker container, and that allows me to then do interesting things like this. As I mentioned before, the other thing I can do is I can tie this into an Apache NiFi flow. Really quickly, Apache NiFi is a great way to just move data around your environment. There's really very little coding. As you can see, it's very much a UI. It's a lot like Visio in this case. And then these are referred to as processors. So these processors themselves have very specific roles. In this case, this one's generate a flow file, so I've got some just data out there to just make. What's interesting though is here. You can see this is where I'm actually calling the model right here with the endpoint that I've created, and I think I'm just sending it age in this case, but I could send it, you could send it the whole data set as well, but I just wanted to test it out. Once I get that reply though, I actually will take it and convert it to a JSON object using these next two processors, and I'll store the results back into Apache Solr. Apache Solr is a lot like Elasticsearch, and there's processors for Elasticsearch as well. And if you go and look at the interface, you can see this is the results right here. So quickly, okay. So 20 minutes in. All right, so that's the end-to-end demo. Are there any questions about how and the why? Any interest there? I tried to get this quickly so we'd have some time for questions. No, you can run it in the cloud, you can run it on-prem. It's just x86 architecture pretty much. But it's more about moving data than it is storage. So when we tell people to size it out, it's more about the diameter of your pipe, your water pipe rather, than the volume of your pool, for example. So, but it's a great way to, I'll go back to NiFi here. There are processors for relational databases, file systems. I mean, you can basically grab data almost off of anywhere, and you can do some pretty simple transformations on it. I wouldn't do any heavy ETL with it, but then you can then route on attributes. So I could send some type of data to one destination source and the other to another, for example. And those can be entirely different destinations as well. One could be a file system and one could be a relational database. So this is, to me though, like what I like about it, it's very simple to use. These are pretty well broken down. And what's the other cool part as well is if you don't have a processor that you like, you can actually write a custom processor. And it's just, it don't do very long, it's very much Java code to actually write a custom processor. No questions, guys? Did I put you to sleep? No, is it the post-lunch kind of? Yes.
How do you, or can you schedule these workflows?
Oh yeah, you most definitely can. Yeah, and it can be you can be asynchronous or in a synchronous style. So you could have it where it's waiting for a file to go into a directory, and then as soon as a file gets in there, it grabs it and it does the workflow, for example. Or you could run it like a cron job. There's different approaches to that. Yes?
One of the challenges seems like a very conventional workflow. One of the challenges we deal with in similar environments is dealing with changing versions of the environment, particularly Spark. Spark conditions change almost a lot of the content. Anything in here that you recommend doing that?
So not here specifically. So this question is it different versions of Spark and how you deal with that in an environment, in an enterprise. So specifically nothing with this, but what we can do with our current platform is actually run Spark on containers. So then you could run different versions of your containers and then hand them off. So that's one approach. Actually, what you can't see here is I did this all with Spark 2.3, and then on the Docker container, it's actually Spark 2.2. I was lucky they work out because, as you know, if you work with Spark enough, the APIs change even in minor versions some. So. But it's a good question. But nothing specifically in this workflow.
So do you have to write this workflow or is it generated based on what you did in Zeppelin?
Okay. The question is if I had to create this workflow, is this something Zeppelin created? No, I had to, this is independent of Zeppelin, so I had to create this specifically for this workflow. And then the Zeppelin workflow is its own piece, but that's the whole notebook, right? So actually with that notebook, I could share that, I could copy that with you, and you could see everything I did and make changes to it, or make your own version, for example, or I could just give you read access, for example, and you could just see how I accomplished that. So it's a great tool for collaboration for teams.
Thank you very much.
Thank you, guys.